For Egypt, the future means finding ways to feed a rapidly growing population. This includes being able to farm in two unlikely locations, the Sinai and Sahara deserts. Building large-scale irrigation infrastructure is impractical in these remote desert regions. Yet across large stretches of barren terrain, an effort is underway to transform the desert into a fruitful oasis using a new technology called Drywater. Drywater is a water-holding gel compound. Because the water is encased into the gel, it does not evaporate in the desert sun. Instead, the water is slowly released into the ground as the gel is eaten away by microbes in the soil. In a world grown wary of the effects of pollution, dry water is completely biologically degradable and free of chemicals that might poison the plant or contaminate the soil. In July 1998, the first scheduled phase of the Egyptian dry water project was complete. A tract of desert containing 1 million blooming trees had been achieved. The Egyptian government now offers subsidized water and land to families willing to leave the cities and move to the desert.
Because the ground here is very dry, we can't have crops and we can't use traditional irrigation for growing crops. But thanks to dry water, we could solve our problem. We grow mango trees as well as peppers, tomatoes and other kinds of fruits. We use dry water like this. We push it into this pipe and leave it for 3 months, and we cover it like this.
Here in the Sahara, the future may spring from new and flourishing communities in a place where once only thirsty nomads roamed. Space-age technologies like dry water and reverse osmosis suggest that there is hope in facing future water problems if these solutions are applied in the right context.